going to switch over to density. So we got to talk about what density is first. It's an intensive property, which means that it does not depend on the amount of substance. Example, water in a cup versus water in a lake is the same density. The water in a cup is not going to weigh more than water in a lake. That quantity doesn't matter, but the density is the same. In extensive property, it depends on the quantity. So that's important to keep that in mind. Density is how packed something really is. The official definition listed here is the ratio of a substance's mass to its volume at a given temperature. And so it's used to identify how pure a substance is, and you can find the mass of a product, you can find the volume of a product by having the density and the equivalent math. That'll be a whole other math situation, but you will learn that as you go along. And it's measured, usually liquid density is measured in grams per ml, and solid density is measured in grams per cubic centimeters. It's important to know those units because those will come in handy. So next we have dimensional analysis, which is the ability to convert between units by canceling out your units. Do you remember from the beginning how we mentioned all of those units? Grams, kilograms, milligrams, all of that stuff. You need to know those. You need to know those conversions. Inches to yards, inches to centimeters, yards to feet, all of that stuff. Basic things to keep in mind that every measurement has two parts, a number and a unit. So if you look here, you see it. We have 1,000 milligrams. 1,000 is the number, milligrams the unit. Always keep track of your units because that is something that is very important. The ability to utilize dimensional analysis properly is extremely useful in science and math fields, which helps prevent situations like incorrect dosing in a pharmaceutical field, incorrect dosing in a pharmaceutical field, incorrect administration of a medication. Units is a big thing. You give someone 1,000 milligrams of heparin instead of like 1,000 micrograms, you'll kill somebody. Something like that. Not really heparin, but something to consider. Medications matter, dosages matter. So you look at that. Things to keep in mind when doing dimensional analysis that you'll slowly work into as we go through. What are your starting units? What are the units of final answer? And what conversion factors are needed? You answer those 3 steps, you go one by one. Let's run through an example. So, looking at this, we see how many nanoseconds are in 3 days. So, what is your starting unit? Your starting unit is 3 days. And then you go one by one. How many hours are in a day? Because you're going from days to seconds. So you need to find a way to convert your conversions over. So you start with days to hours. So in one day you have 24 hours. In 1 hour, you now have 60 minutes. In 1 minute, you have 60 seconds. And in 1 second, you have 10 to the 9 nanoseconds. That is important because you need to know that chart that I mentioned before, the one with King Henry, to be able to know this. That chart is important. So, as you can see here, when you do the math out, you'll be multiplying like 3 times 24 times 60 times 60, which gives you 2.6 times 10 to the 14 nanoseconds. Now, 10 to the 14 just means 14 zeros. So it's like instead of writing all of that out, you just put this 10 to the, a caret number up there. But it's important to make sure that you cross out your units because not every dimensional analysis will be as straightforward as this. So you need to think, you need to work, and you need to be slow but careful. Start slow, start careful, and you'll always get your answer. All right, let's go next. So here's some analysis problems. Why don't you try these on your own? I'm going to give you like 30 seconds, or I'll give you a minute. Pause this video, and when you're done, go to the next slide, and we will go ahead and go over them together. All right, so having paused that video and gone through it, let's hope and see if you got it right. So you start with the first one. We have 568 centimeters to yards. So we start with 568 centimeters. We convert that to inches because inches is the other conversion. So you go 2.54 centimeters in 1 inch. So and then normally you would cross that out. So centimeters are gone, and now your unit is inches. And 12 inches gives you 1 foot, and 3 feet gives you 1 yards, which when you multiply, so 568 divided by 2.54, divide by 12, divide by 3. If you're using a TI-84 calculator, however, TI-84 calculator or TI-33, I like to use TI-30XS. It has a actual function for dimensional analysis that you can use. That's very, very beneficial for this, and that would help you as well. But to be able to learn to do this by hand is one of the most important things that you could do. So when you do all of that, you get 6.21 yards, which is the correct answer. Next up, we have what is the volume in, next one's a little difficult. What is the volume in nanocubic meters of a 155.6 pound sample of pure copper, given that the density of copper is 8.96 grams per cubic centimeter, and 1 pound is 453.6 grams. Sometimes they will give you conversions like this, where they tell you 1 pound is something. If they give you that, you don't use what you know, because sometimes they'll say like 1 pound, like 2.2 pounds. You know 2.2 pounds is 1 kilogram, but sometimes they may say, assume that 1 kilogram is 2.4 pounds. In that case, you will use 2.4. Use what they give you, but make sure you're doing things properly. So in this case, let's go start from the beginning. You start with, what are you starting with? 155.6 pounds. So you're starting with 155.6 pounds, and then you use the conversion they gave you. 1 pound gives you 453.6 grams. And then you look, because now you have grams, and they gave you a density. Density in solids is what? Grams per centimeters cubed. So you go ahead, you convert that, so you divide by 8.96 grams, which gives you whatever in centimeters cubed now. Now you have to convert centimeters in cube to meters cubed, because you want to go to nanometers cubed. I never advise converting directly from centimeters to nanometers or anything like that. Always go straight back to meters and then add or then multiply by the whatever you need to get to either nano, milli, or whatever. Always go back to meters first. So then you're in meters. Now you just multiply by nanometers, and you get that 7.88 times 10 to the 24 nanometers. So that's all I had for today. This was basic introduction. The next lecture is I'm going to go about atoms, states of matter, something along those lines. Haven't figured it out yet, but we're going to go ahead. We're going to get one by one through all of this. We're going to get you guys started. We're going to get you guys chemistry masters. And if you have any questions or concerns, again, please feel, or questions, concerns, or if you'd like to see any other videos or any improvements, any feedback or anything you guys have, put in the comments down below and we'll get started. Thank you. Have a good day.